Okay, so the three elementary row operations, okay? So the first one is that you can interchange two rows. It's basically just swapping a row, okay? Now the second one is, let's say multiply a row by a non-zero constant. Okay? And the third one is add a multiple of a row to another row. Okay, now it might seem that 2 and 3 are kind of the same thing. Well, if you can just multiply a row by a constant, but what this is going to do is this is actually going to say, when we say multiply a row by a non-zero constant, if we want to turn something into a 1 or a 2 or whatever, then you can just you can go ahead and say, all right, I'm going to take a constant and multiply by that entire row to convert it. So what is an elementary matrix? Okay, so we have our elementary row operations. Okay, these are three things we can do. All right. And then we have the concept of what is an elementary matrix. Okay, so an n by n matrix, meaning it has to be squared. Is an elementary matrix if it can be obtained that's an E. Okay. Let me write that. From the identity matrix okay, and that's going to be I, which is n by n, by a single, underline that one, okay. Give everybody a second to write that down. So, if you take an identity matrix, which is n by n, we're going to work mostly with 3 by 3. And if you can do a single row operation, elementary row operation on it, that gives you an elementary matrix. And so, we've actually already seen elementary matrices before, okay? So what is the elementary matrices that we've actually already seen? Well, that would be the elimination matrices. The elimination matrices that we were using for Gaussian elimination. Okay. So let's look at these three different types of row operations and what an elementary matrix actually does. Okay. So if we want to create elementary matrices with their row operations. So let's look at the first one. Okay, so our first property. We're going to begin each one of these. So this is going to be covering our row operations. Okay, so that first one. If we take the identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1, okay. Now, the first problem says interchange any two rows. Okay, so we can interchange rows. What if we said we're just going to interchange or another word for this, I'm going to swap the rows. What would we end up getting? We'd have 1, 0, 0, 0, 0, 1, and 0, 1, 0. Okay. So this is that first operation we can do. Okay, so we can take the identity matrix and we can interchange them, we can swap them. And so then you have to think about what would this elementary matrix do if I had to act upon a matrix. Okay, so we have a 3 by 3. And so let's have it actually just act upon a matrix. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it would be 1, 2, and 3. All right. Now, 1, 0, 0, acting upon this, you have to have this row act upon that column. What is it going to pick up? It's just going to pick up 1, 2, and 3. Now, if you have this, this row operation right here, 0, 0, 1, acting upon this one right here, that 1 is going to pick up the 7, then the 8, and then the 9. And so, and then this one, 0, 1, 0, is going to pick up 4, 5, and 6. Okay. So, what is the row? All right, so this is the elementary matrix that is going to be associated with, if I take the identity matrix and I just swap 2 rows in that, okay? All right, so what's going to happen if I do that? The elementary matrix that I've created, what it's going to do is it's going to swap the rows. It's going to take this bottom row. So what did I do? I swapped the bottom row and the middle row. So when the elementary matrix that is associated with that, that interchanging, when it acts upon a matrix, what's it going to do? It's going to swap the rows, okay? Okay, so that's the first one. It has to do with kind of, it does not have to do with all permutation matrices, because an elementary matrix can only do one, you can only swap with one row, because you're only allowed one row operation, okay? Some permutation matrices will swap a bunch of rows, especially if you get up to n by n matrices. Those aren't elementaries because you can perform more than one row operation upon them. Okay. Now, the second one says that I can multiply by a number. So let's take our identity matrix, 1, 0, 0, 0, 1, 0, then 0, 0, 1. Okay? And we can multiply a non-zero constant. Okay, so let's say we're going to take this row and we're just going to multiply by 3. Okay, so the elementary matrix that would be associated with this would be 1, 0, 0, 0, 1, 0, 0, 0, and 3. Now let's have that act upon the same matrix. It's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that would be 1, 2, and 3, 4, 5, and 6. Now 3 times 7 is 21. That's 24. And 3 times 9 is 27. Okay. So, what does this do? It puts a constant, a non-zero constant, into the diagonal, and then this elementary, what does the elementary matrix operation do? So the elementary, all right, we did an elementary operation on the identity matrix. And so when you do an elementary operation on an identity matrix, meaning, okay, I'm taking this and I'm multiplying by 3, what is that going to do? That's going to perform that operation onto any matrix that is the same size, okay? So, well, it doesn't have to be exactly the same size. The size of the row would have to be the size of the column, but the number of columns can, go backwards and forwards. Okay. All right. So this is just basically, I could say I can multiply an entire row by a constant. Okay. Now let's look at our last one. So the last one says, so the third one. One, 0, 0, 0, 1, 0, 0, 0, 1. We always begin with our identity matrix. Okay? I'm going to take this row and I'm going to multiply by -4, and I'm going to add downwards. Okay? So yeah, so I'm following number 3, so that's adding multiple of a row to another row. So add, let's say, row 1 multiplied by -4 to row 2. Okay. So that would become 1, 0, 0, -4, 1, 0, and 0, 0, and 1. Okay, now let's have this act upon that same matrix again. One, 2, and 3. Okay, so -4, 1 acting upon this. So what is going to happen with this thing? When -4, 1, 0 acts upon this guy, it's going to take the first row, it's going to multiply the entire first row by -4 and add it to the row below it. So 1 times -4 plus 4, that's going to be 0. Okay, -4 times 2 is -8. -4 times 3 is -12. -12 plus 6 is -6. Okay? Means 7, 8, 9. Okay. And so what does this lead to? This is the elimination matrix E21. So it's the elimination matrix of the 2-1 position. Second row, first column. And so what does this do? When this elimination matrix E21 acts upon this guy, it's going to eliminate the position E21. Okay, so this is entitled an elimination matrix, and it is an elementary matrix. But you can have an elementary matrix of multiplying one row by a number and adding it to the next one, it doesn't have to be an elimination matrix. You can just say, all right, I'm just gonna have this act upon this, and you can, if I put 1, 2, 1, 1, 0, 0, 2, 1, 0, like that, yeah, take the first row, multiply by 2, add it to the next one. So, for the filming, I think this is off by just a little bit. I don't know if you can see the top of that on the other film. But anyway, so that's what, that's how we get to an elimination matrix.